So now that we've worked on two types of horizontal transformations, we've got the period and also the phase shift. Let's try to put them together and see what happens. So let's take something like let's try to do sine of maybe 2x minus pi over 4. All right. So first, always do the period first. Always do the thing that's multiplying it first. Kind of like equilibrium. Always, with equilibrium is like added or subtracted at the end, and you do that later. Otherwise, weird things will happen and you'll flip your equilibrium. Here, always do your period first, because if you do the adding or subtracting part at the end, then it'll be like the period is applying to the phase shift also. That's not what we want. So yes, period first. That's takeaway here. So let's try to graph sine of 2x. Well, we know that 2p equals 2 pi. Period is p. 2p equals 2 pi. So period is just pi. So our graph would look something like this. So this would be pi now. So it would be negative pi. Now let's do sine 2x minus pi over 4. So this is a phase shift of pi over 4 here. So let's or negative pi over 4. So when we plug in 0 into this, well, originally when we plug in 0, we're right here, but now when we plug in 0, we're at negative pi over 4. So we want to take where it goes to negative pi over 4. Well, this is negative pi over 2. So this right here is negative pi over 4. And we're going to shift that to the 0 part. So now our function is going to look like this. And period is still 2 pi. So when it reaches there again, it should be at, so period is still pi, my bad, should be at negative pi, and when it reaches here again, it should be at positive pi. Then this is like pi over 2, then there's like negative pi over 2, and so on. Let's do one more. Let's do tangent of about 2/3 pi x plus 1. Yeah, let's do that. So the period, remember, first we want to graph our, forget about the phase shift. Let's just graph tangent of 2/3 pi x. So originally the period is pi, so we have to say 2/3 pi times the period equals pi. So that means 2/3 times period equals 1. So that means period equals 3/2. I'm just going to write that as period equals 1.5. So let's graph this. So now, here to here, that's 1.5. Here to here, 1.5. Here to here, 1.5. Let's draw in our asymptotes. And there is our graph. Now asymptotes are at, this would be 0.75 then, negative 0.75, and negative 2.25, so it would be 2.25. Now, when we plug in 0, we're originally right here, but now when we plug in 0, where we would be at 1. So at 1, we're right about here, roughly. So now this part shifts back over there, and we draw our graph. So now it's going through about right here. Yep. Actually, that looks kind of a weird squiggle. Let's try to make this a little bit better drawing. Yeah, that's a little bit better. Okay. So now we're shifting everything back by 1. So this asymptote that was originally at 2.25, that's shifting back to 1.25. This asymptote that was originally at 7 point, that's shifting back to negative 0.25. And then we continue drawing. So period is 1.5, so this is like negative 1.75, and then this one will be 2.75, and that's our graph. So remember, again, always period first, phase shift second. Otherwise, bad things will happen.